Okay, in example 6 we're going to look at an example involving trigonometric functions. So we're going to do some U substitution with trigonometric functions. So again, we're looking for function composition, and it should be clear that that sine square of 3x is a function composition. It's actually a three-way composition, but we'll just take the inside function as sine of 3x, and we'll let that be u. So taking the derivative of that, we're going to get cosine 3x times 3, and rewriting in differential form, we get u is equal to 3 cosine 3x dx. So you can see here that we have we're looking for cosine 3x dx, and so we're going to need to divide that by 3. So now we can swap out the whole cosine 3x dx for 1/3 du. And the sine of 3x, not sine square of 3x, but just sine of 3x is going to become u. So we're ready to rewrite this as 1/3 times the integral of u squared du. It became so much simpler than what was there originally. And we're ready to integrate that. U squared becomes u to the third over 3. Bring the 3 out and we get 1/9 u to the third plus c. Swapping back in, we get 1/9 sine of 3x to the third power plus c. Okay, so that's an example of integration by substitution with trigonometric functions. I'll give you one that you can try. So that would be the integral of sine x over cosine square of x dx. And you can pause the video, work on that, and I'll give you the solution in a few seconds, or the answer in a few seconds. Okay, and so your answer to that should be secant of x plus c. If you got that, feel free to move on. If you'd like to see how that works out, I'll go through that solution right now. Now, in rational functions involving trig functions, you usually want to use the denominator as your u substitution, as your u, because you want the numerator, you want the dx to show up in your numerator. Well, let's see what that looks like. So cosine square of x is really just secant square of x. So we can rewrite this as sine x times cosine x quantity to the negative second power. So instead of writing it as secant, I'm just going to leave it in this way. Now we can see clearly that our inside function is cosine. So u is equal to cosine of x, and du is equal to negative sine of x dx. I have a sine x dx without the negative in the integral, and so I'm going to multiply both sides by -1. And so I'll swap out the sine x dx for negative du. I'll swap out the cosine x for u. Rewriting, I get negative integral of u to the negative second du. And the antiderivative of u to the negative second is going to be u to the -1 over -1. So the negatives will cancel, and I'll get u to the -1 plus c, which is 1 over cosine x plus c, which is just secant x plus c. And that's what we were looking for. All right, so I will go on to further examples in the next video.